Hello and welcome to PhysioEx exercise 9, the renal system physiology, activity 1, the effect of arteriole radius on glomerular filtration. So glomerular filtration will be the dependent variable and our independent variable will be the arteriole radius. Here we refer to with arteriole radius, we refer to the afferent arteriole radius and the efferent arteriole radius. So let's start the experiment. So the objectives are to understand the terms, what a nephron is and the glomerulus and the glomerular capillaries. And we must understand the renal tubules and what is the filtrate and the Bowman capsule. And we have discussed all of that in class. So let's get to the experiment. So the pre-lab says, what is the approximate number of nephrons in a healthy human kidney? It's about 1 million. And which of the following list the anatomical structures in the correct order as they are encountered by blood cell during the process of filtration? So the blood enters through the afferent arteriole, goes through the glomerular capillary, and then exits through the efferent arteriole, and then starts heading towards the peritubular capillary. That sounds like the right answer. And then the Bowman's capsule is connected to the beginning of the Bowman capsule is connected to the beginning of our proximal convoluted tubule exactly. And the functional unit of the kidney is obviously the nephron. And during the process of renal reabsorption, fluid and solutes move from in renal reabsorption. So in reabsorption, we take the glucose and we take solutes from the tubule into the peritubular capillary. Sounds perfect. Okay, now let's continue. So what we're gonna do here is, so this is our blood. And what happens is blood is gonna start flowing through the afferent arteriole. That's the afferent arteriole. If we increase, if we increase the radius, you will see the radius of the arteriole is going to increase. And this right here is going to be our Bowman capsule. And that's how we're going to measure the glomerular capillary pressure and the glomerular filtration rate here in this capsule. And then we will exit through the efferent arteriole. And then these are our peritubular capillaries, and then blood will be, and this is the vein, the renal vein, and then blood will be successfully filtered, is in a dialysis. So what we're going to be doing in this experiment is that we're going to be modulating, we're going to be changing the efferent arteriole's radius, and later on the efferent arteriole's radius, and we're going to see what effect will changing, when I say changing, I mean increasing the arteriole radius or decreasing the arteriole radius, and then we're going to see what effect are these changes on the radius of the arteriole. What changes are they going to have on the glomerular capillary pressure and the filtration rate? Okay, and then we're going to do the same thing for the efferent radius. So let's begin. It says that note the default values for afferent radius, efferent radius, and pressure. Change these values to be 0.5 millimeters afferent radius. So 0.5 afferent, okay, and 0.45 efferent, 0.45 efferent, and 90 millimeters of mercury pressure. Okay. Throughout this activity, hold these values constant unless instructed to change a specific variable. So select start to begin the glomerular filtration. So we click on start and you see afferent arteriole is the Bowman capsule, and then you see the filtration taking place, and that's the urine forming in the this is the urinary bladder, and that's the peritubular capillaries. And that's the renal vein, and now this is the blood that has been filtered. And these are our values recorded. So now that's the last amount of urine, stored, and that's our blood. So let's record. So now we have recorded. Our afferent radius was 0.5, our efferent radius was 0.45, and the glomerular pressure came out to be 55 millimeters of mercury, and the filtration rate was 124.9 milliliters per minute. And the urine volume that came out was about 200.44 milliliters. So now let's do the same thing again. Change these values to be 0.5, 0.4. So we have done that. So let's move on to the next step. We recorded the data, select refill. So now we refill everything. So now we restored everything to baseline. And then let's see what, so now they're asking us, what will happen? So now that's a prediction, that's a hypothesis. What will happen to the glomerular capillary pressure and filtration rate if you decrease the radius of the afferent arteriole? So if I decrease the radius of the afferent arteriole, less blood is going to come in. So that's going to give me, the pressure will decrease and the filtration rate will, both the pressure and filtration will decrease, both. So that's my hypothesis. So now let's find out in the experiment. Decrease the radius of the afferent arteriole into 0.45 by selecting the minus button besides the afferent radius display right here. Okay, then let's start. So now we have started, and let's later on record the data. See, the urine is forming and the blood is being filtered, and reabsorption is happening in the peritubular capillaries. And then there's the last amount, and that's the last amount of urine forming, and that's my bladder. So now let me record the data. Well, isn't that interesting? When my afferent radius was 0.5 millimeters, my glomerular filtration was 55, glomerular filtration rate was 124. When I dropped it to 0.45, what happened to the glomerular pressure? It went down, and the filtration rate also went down. Now, let's restore everything to baseline. Now, you will now observe the effect of incremental decrease in the radius of the afferent arteriole. So we're going to be decreasing by 0.05 up to 0.35. So we did 0.45. Let's do now 0.40. Start. Then we're going to record the data. That's the amount of urine volume that is being formed in the bladder. So interesting, when 0.5 radius gave me 200, 0.45 gave me 179. Now let's look at 0.35. What is it going to give me when I record my data? Record data gave me 143, and the glomerular pressure went down to 48, and the filtration rate went down to almost half when compared to 0.45. Now let's calibrate. Let's refill. Now let's go down to 0.35. Now let's start. So now everything is being filtered through a afferent radius that is no longer 0.45, 0.40, but rather 0.35. So now let's find out how much urine is going to be formed. Obviously, it's going to be less because we see a trend. The more we decrease the afferent radius, the more glomerular pressure drop we're going to be having. Record data. 0.35 gave me a glomerular pressure that is 46, urine that is 76, and filtration rate that is 14. So now we have observed up to 0.35. So let's calibrate everything. And let's see. Now, what will happen to the glomerular capillary pressure and filtration rate if you increase the radius? So now we're no longer going to be dropping the radius. We're going to be increasing. So now I see the opposite is going to happen. If when I decrease the radius, everything dropped, the urine volume dropped, the glomerular filtration rate dropped, and the glomerular pressure dropped. So now if I increase, everything is going to increase. I assume both pressure and filtration rate will increase. Okay, increase the radius of the arteriole to 0.55. Let's go up to 0.55. And let's start the experiment. So now we are bringing in the blood through a radius that has increased to 0.55. Let's see how much urine is forming. So 0.55, that's the largest radius we've dealt with in the entire experiment thus far. Now let's record the data. 0.55 gave me 58, 172, and 212. That's even more than 0.50. So now I see a trend that I increase the afferent arteriole, I increase the urine output, I increase the glomerular filtration rate, and I will also increase my glomerular pressure. Let me refill everything and continue with the experiment. Now increase the radius to 0.6. There we go. And now let's start the experiment. So record data, I increased it to 0.6, and voila. The urine volume has increased the most. Glomerular filtration rate increased the most to any other value. So the more I increase the afferent radius, all the other variables will increase. Let me refill everything because I recorded my data. And now, okay, caffeine consumption leads to increased urine formation. So I increase my urine formation. From the results of the experiment thus far, you may propose that caffeine constrict. No, it will not constrict. It will dilate. Caffeine reduces blood pressure. No, caffeine dilates afferent artery. That makes sense. Submit question. What will happen if the glomerular capillary pressure, to the glomerular capillary pressure and filtration if you decrease the radius of the efferent? So now we're decreasing the outlet. If you decrease, that means if you decrease the efferent arteriole, that means you will make the flow, the exit, the exit or the outlet narrower. So that means fluids will be in the capsule for a longer time, and that will increase the filtration rate, and that will increase the glomerular pressure. So both pressure and filtration will increase. So now there is an inverse relationship. There is an inverse relationship between glomerular filtration pressure and filtration rate with the efferent arteriole. So if I decrease the radius of the efferent arteriole, I increase the pressure and filtration rate. And if I increase the efferent arteriole radius, I will drop the pressure and filtration. But for the afferent arteriole, it's not an inverse, it's a direct relationship. I increase the arteriole, the afferent arteriole, then the pressure and filtration will increase. And if I decrease the afferent arteriole radius, then that means the pressure and filtration will drop. Okay, decrease the radius of the afferent arteriole to 0.5. This is afferent arteriole to 0.5. So the afferent was dropped to 0.5. Yeah. And now let's run the experiment. Record data. Now, the next step would be refill. And now we're going to be decreasing the efferent arteriole by 0.05 up to 0.3. Okay. Now, start. So I dropped from 0.45 efferent arteriole to 0.40. Record data. Now, refill. You see, the more I drop the efferent radius, the more the glomerular pressure increases, the more the glomerular filtration rate increases, and the more urine volume increases. Record data. And then the last thing is, let's refill one more time. 0.3 start. You see, since I started decreasing the efferent arteriole, the more I decrease the radius, the more glomerular filtration rate would increase, the more glomerular pressure increases, and the more urine volume that I get. Now, this is a reading for 0.3 efferent radius. Record the data. So for 0.3, I had the most glomerular pressure and glomerular filtration. Okay, so when you are in the desert and dehydrated, which of the following arterial combinations would benefit you the most? If you are in the desert and dehydrating, so that means there is a drop. There is a drop in my blood pressure. So that means I want to dilate my afferent arteriole and constrict my efferent arteriole. It's an afferent constriction. So I need to constrict my afferent arteriole to drop my filtration rate, and I need to dilate my efferent arteriole to allow for escaping, for the escaping of blood from the filtration. If you increase the afferent arteriole radius and keep all other variables constant, the glomerular filtration rate would increase. If you decrease the efferent arteriole radius and keep all the variables constant, the volume of the urine flowing into the urinary bladder would increase. If you increase the efferent arteriole radius and keep everything constant, it will drop. If you decrease the afferent arteriole radius and keep all the The volume of urine flowing into the urinary bladder would increase. Two primary functions of the kidney: acid-base balance, electrolyte balance, fluid balance, osmolarity regulation, metabolic waste, and toxins removal, regulation of arteriolar blood pressure. What are the components of the renal corpuscle? The renal corpuscle is made up of my glomerular capillaries and Bowman's capsule. Starting with the renal corpuscle, list the components of the renal tubule as they are encountered by the filter. That'd be proximal convoluted tubule, descending loop of Henle, and ascending loop of Henle, and distal convoluted tubule, and collecting duct. Describe the effect of decreasing afferent arterial radius on glomerular filtration rate. Okay, so afferent arterial radius has direct relationship with glomerular capillary pressure and filtration rate. Meaning if I increase the afferent arterial radius, the glomerular capillary pressure will increase and filtration rate will increase. And the opposite is true for efferent. It has an inverse relationship. Describe the effect of increasing afferent arterial radius on glomerular capillary pressure and filtration rate. Yes, so the more I increase it, the more it will increase. Yeah. Decreasing efferent. So it has an inverse relationship. So if I decrease efferent, I will increase glomerular capillary pressure and filtration rate. Describe the effect of increasing the efferent radius. So if I increase efferent radius, I decrease glomerular capillary pressure and filtration rate, since it has a negative or inverse relationship. Okay, and that will be all for today.